1055. Gas containing 0.8 mole percent component A. So that the gas here is the gas entry and it contains 0.8 mole percent A. So Y1 is equal to 0.008. Is to be scrubbed with pure water. So this is my water, pure water. So therefore X2 must be equal to 0 in a packed bed. So this is my packed bed here. Um, Column to reduce the concentration of A to 0.1 mole percent. So Y2 should be equal to 0.001. The inlet gas flow rate, so V1 is equal to 0.1 kilomole per second. And since it is dilute, we assume V1 is equal to V2 and let's call it equal to V. So here V2 is equal to V1 is equal to V is equal to 0.1 kilomole per second. Okay. And here water is entering at 3 kilomole per second. So L2 is 3 kilomole per second. So since it is dilute, again dilute, we assume L1 is equal to L2 is equal to L. Let's say that's equal to 3 kilomole per second. Right. So the very first thing we can do is do a mass balance or component balance, and of course for A, and therefore we can just say that V times Y1 minus Y2 is equal to L times X1 minus X2. We know X is almost equal to X and capital Y is almost equal to small y for dilute solutions. So we can say V times Y1 minus of Y2 is equal to L times X1 minus of X2. Since we know V, which is this one here, since we know Y1 and Y2, which is this one and this one right here, and we know L, which is this one right here, and we know X2, which is equal to 0, we have seen. So we can calculate the value of X1, and that comes to be equal to 2.33 times 10 to the power minus 4. The detailed calculation is shown in our website. Now, let's find out, we have to find out the number of transfer units. So here it is for NG, when it is the number of transfer is based on individual mass transfer coefficient. If we based on overall mass transfer coefficient, so it should be NOG, and it is modified as Y2 times Y1 dy over Y minus Y star instead of Yi, and that of course comes to be equal to Y1 minus Y2 divided by Y minus Y star log mean. Okay. So here instead of Yi, we just put Y star here. So how do we do it? Y minus Y star. So we know Y1 and Y2, that's not a big problem. Y minus of Y star log mean, that's defined as Y1 minus Y star minus of Y2 minus of Y2 star divided by natural log of Y1 minus of Y1 star divided by Y2 minus of Y2 star. Now, how do we know Y1 and Y2? That's not a big problem. How do I know Y1 star? Y1 star is given by the equilibrium relationship MX1 here. And if the slope of the equilibrium curve is 24, slope is basic, so therefore n is equal to 24. The relationship is y is equal to y star is equal to mx. Okay. So that's what we come here. Y1 star is mx1 and y2 star is equal to mx2. Since we know x1 and x2, we can calculate y1 star and y2 star, and therefore we can calculate this value here, and that comes to be equal to 1.602 times 10 to the power minus 3. Okay. So therefore, we can now calculate. We know the value of y11 as y2. So this is 0.008 minus 0.001 divided by this value here. And it comes to be equal to 4 point something. The value comes around 4.4. Therefore, in OG, the number of um, transfer units based on the gas side overall in OG, O stands for overall, comes to be equal to 4.4. So that's my answer. Okay. Second method, of course, just for the note, since it is a dilute solution and if the operating line and the equilibrium line both are linear, we can use Kramser equation shown in website, and we should get exactly the same value. NOG comes out to be equal to 4.4. This, of course, this is normally used for staged operation like trays, etc. This method is used for packed beds.